Hey everybody, this video is going to be about solving quadratic systems. We've already learned different ways in how to solve systems of linear equations. For example, the system that is on this page, that 2x plus 3y equals 22 and y equals negative 2x plus 6. That is linear equations. And we've learned how to do that, to solve it by a table, graphing, substitution, elimination, how to use your calculator to calculate the intersection. So before we move on to quadratic systems, I'd like to do a review problem and remind you how to solve a linear system. So the first option here is to solve with graph paper. So a lot of times you'll take that first equation and you basically have two options. You can either get it into slope-intercept form by solving for y. So in that case, I would subtract 2x and divide by 3 on both sides. I get negative 2/3 x plus 22/3. This is where your y-intercept is 0, 22/3, and the slope is negative 2/3. Make a little space here. And then the other option would be with intercepts. So if I use that equation and I'm trying to find my x-intercept, I'm going to plug in y is 0 and I get 11. And if I plug in x is 0, then I get 22/3. Okay? And I could plot those two and then graph it. I'm going to go ahead and choose the option where we're going to get into slope-intercept form, and I'm going to plot my y-intercept, which is 22/3. Let's see, that's the same as 7 1/3. So 1, 2, 3, 4, 5, 6, 7 1/3. And then I'm going to go down 2, right 3. Down 2, right 3. Get a couple points there. And then I'm going to use a straight edge and graph the equation. After that, I've got this y equals negative 2x plus 6. So with y equals negative 2x plus 6, I'm going to go to 6. And let me grab a different color here. I'm going to go to 6. 1, 2, 3, 4, 5, 6. And from there, I'm going to go down 2, right 1, down 2, right 1. Keep in mind, you could go up to left 1. And once you get a few points, go ahead and graph your function. Now, the solution is going to be where they both intersect. Okay, so in our case, that is here at, it looks like negative 1. Let's see, 1, 2, 3, 4, 5, 6, 7, 8. Negative 1, 8. That is our solution. I can also solve by substitution. So if I have this 2x plus 3y equals 22 and y equals negative 2x plus 6, I can go by substitution. Since the second equation is solved for y, I'm going to substitute that negative 2x plus 6 in for y. So let me write that out. 2x plus 3 times negative 2x plus 6 equals 22. Well, that's 2x minus 6x plus 18 equals 22. Or negative 4x equals, let's see, subtract 18 from both sides, that's 4. So x is negative 1. And then you're going to solve and plug it in for y. So negative 2 times negative 1 plus 6, well, that's 2 plus 6, or 8. That means y is 8. That gives me the coordinate, negative 1, 8. I could solve by elimination, and with elimination, you want to get both of your equations in standard form. So the second equation, I'm going to add 2x to both sides. Now, I have to choose to either eliminate my x's, which means I would just need to multiply one of them by a negative, or I could multiply my y's, and I would multiply the second equation by negative 3. I'm going to choose just to multiply here by a negative. So that way I can go ahead and add my two equations and get 2y equals 16, which means y is 8. Plugging it back into an equation, I'm going to choose one of the originals, and I'm going to choose the second one. 8 equals negative 2x plus 6. I'm going to subtract 6 from both sides and get 2. That means x is negative 1. So the solution is negative 1, 8. You'll notice, regardless of which option I choose, I'm always going to get the same solution. What it means is that when I plug in x equals negative 1 and y equals 8 into each equation, it makes both of them true. So let's take a look and check on how to do this on a calculator. So the first thing you've got to do is write down your equation in slope-intercept form. So type that in. I'm going to go parenthesis negative 2 divided by 3 end parenthesis x plus parenthesis 22 divided by 3 end parenthesis. And then I'm going to enter the other equation, which is negative 2x, so negative 2x plus 6. And I'm going to graph both of them. And you'll notice they both intersect. So I'm going to click intersect, and for you, you would hit second trace, which is your calculate, go down to intersection, push enter, and then you're going to get your cursor somewhat close to where you think that solution is, and hit enter, enter, enter. And you should get the point negative 1, 8 as a solution. Okay? All right, so that is solving a system, a linear system. So let's take a look at our next example. This is a quadratic and a linear. You could have two quadratics in your system, a quadratic and a linear. You have lots of options, but you're still going to kind of treat it the same. Here's what I see. In that y equals the quantity x plus 3 quantity squared minus 2, that's in vertex form, which means I could pull out the vertex, which is going to be negative 3, negative 2, and I know that it opens up. Let me write that down. Opens up. And the reason I know that it opens up is because the a value is positive. Now, one thing that I need is that I'd like to have the y-intercept. The y-intercept I can get from plugging in 0 into the equation. Well, plug in 0 into that first equation. 0 plus 3, 3. Quantity squared, 9, minus 2, 7. The y-intercept is 0, 7. Let's graph what we have so far, and we'll do that in red here. I've got negative 3, negative 2. I also know with parabolas the axis of symmetry is going to be x equals negative 3. It's that x equals h. And I know that it goes through 0, 7. 1, 2, 3, 4, 5, 6, 7. Okay. I also know that it opens up. So I have half of my parabola. I need to graph the other half by reflecting the point 0, 7 over the line x equals negative 3. So that means I will have this coordinate. And then I can finish off my parabola. Now let me grab a different color, and we will do the second equation. So y equals x plus 3. That's linear. Y-intercept, 3. From there, I have a slope of 1, up 1, right 1, which is the same as going down 1, left 1. And draw your line. It looks like we've got two solutions here. One here and one here. So it's where the parabola and the line intersect. And it looks like we have coordinates at 1, 2, 3, negative 4, negative 1, and also at negative 1, 2. Okay. Now, we can solve this by substitution as well. To solve it by substitution, let me rewrite these equations real quick. I'll show you what I mean. We're going to substitute one equation in for the other. So I'm going to choose to substitute the first equation into the second for y. So I have x plus 3 quantity squared minus 2 equals x plus 3. Now, you've got to FOIL and multiply out your x plus 3 quantity squared, and you're going to get x squared plus 6x plus 9. I have a minus 2 equals x plus 3. That's x squared plus 6x plus 7 equals x plus 3. Solve for x, actually not solve for x yet, because I've got to get everything to one side. So I've got to subtract x from both sides and subtract 3 from both sides. Gives me a 0 on the right. I get x squared plus 5x and then a plus 4. So now I have a quadratic function, and there are different ways to solve a quadratic function. So you can either factor, you can complete the square, you can use quadratic formula. I'm going to choose to factor. My two linear factors would be 4, x plus 4, and x plus 1. So basically I'm looking for two numbers that multiply to get 4 but add to get 5. Using your zero product property, x plus 4 equals 0 or x plus 1 equals 0. So that means x is either negative 4 or x equals negative 1. Notice I have two solutions, which means I need to find the y values. I have to substitute that back up into x plus 3. So I have negative 4 plus 3, which is negative 1. And I have negative 1 plus 3, which is 2. So I get coordinate negative 4, negative 1, and I get coordinate of negative 1, 2. Notice, exact same coordinates that we got up here when we were graphing. Okay, now let's solve it with our graphing calculator. So let me get to my y equals, and I need to clear out both of these equations. And then I'm going to enter the first equation, parenthesis, x plus 3, end parenthesis, squared, minus 2. And then the other equation is x plus 3, x plus 3. And I am going to graph it, and I'm going to push intersect. And notice I get the same result. I get the point negative 4, negative 1, and negative 1, 2. So how you would do it on your calculator is graph it, and then you would want to calculate the intersection, so second trace, go down to intersect and push enter, and then get the cursor somewhat close to where it intersects the parabola and the line, and then push enter, enter, enter. And then you're going to have to go through that process all over again. Second trace, which is your calculate, choose intersect, get it to the other point, move that cursor close to the other point, push enter, 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 and that's how you're going to get your intersection points using your graphing calculator. So guys, you're very similar to graphing linear systems. The difference with a quadratic system is that you just have to remember all of your information on how to graph a quadratic function.